Okay, let's look at this next question here. This next question, it is, let's just get the right brush here before I start answering. Ooh, let's not be yellow. Let's be blue. Okay, it says name the smallest angle and the longest side in each of the following triangles. Now, so the rule that they just taught you is that the smallest angle is opposite the shortest side and the longest angle is opposite the longest side is opposite the largest angle. So if we had to look here at this triangle, we need to know all of the angles in order to figure out which is the smallest angle. So we know this is 110, we know this is 40. So 110 plus 40 equals 150 degrees, and the interior angles of a triangle add up to 180. So this angle here must be 30 degrees. Okay, so if we look here, 110, 40, 30, this must be the smallest angle. So to name the smallest angle, you either say P and you put the little cap on its head to say angle P, or you can more correctly name it TPM. Can you see that? TPM, because when you looked at the angle, you went from T to P to M to label the angle. Then it says to you, which is the longest side? The longest side is opposite the largest angle, which is this angle. So this side here has to be the longest side, and this side's name is PM or MP. It doesn't really matter. Now in this triangle, here is a right angle. Here is a 30-degree angle. So 90 degrees plus 30 degrees is 120 degrees, and we know the angle sum of a triangle is 180 degrees. That means this angle here must be 60 degrees. So the smallest angle is this one over here. So it is TPM, or you could say angle P if you preferred. Now, which is the longest side? 30 degrees, 60 degrees, 90 degrees. 90 degrees is the largest angle. So what is opposite from here? Side PM is the longest side here as well. Now this last triangle C, there's the markings here which shows you this is an isosceles triangle. So remember, in an isosceles triangle, it's the angle opposite the sides that are congruent. So you look at the congruent sides and you look at the opposite angle. So this angle here is 70 degrees as well. So if this angle 70 and that angle 70, 70 degrees plus 70 degrees is 140 degrees. So 180 minus 140 means this must be 40 degrees over here. So the smallest angle is 40 degrees, and it is angle PMT. And remember to put the little copy on the M, and it's PMT. Can you see it's the angle described between those two lines? Or we could have written angle M like that. Now, which is the longest side? Here the problem is the longest side is opposite the largest angle, but these two angles are equal. So this side here is long, okay? Can you see this side here? And this side here is long. So we can say TM is the same length as PM. Okay, so TM equals PM, and they are the longest side. And there we go, this question has now been answered. And now let's look again at the next question. Okay, this one's a little bit more interesting. It says calculate the value of x and y. And look, can you see here? It gives you the value of x, and then it gives you a reason. Okay, so in all of these, the answer goes over here and the reason goes over there. So let's see what color pen we have here. So what kind of a triangle is this? Immediately I can see that this triangle is an isosceles triangle because there are these markings here. So the angles opposite the congruent sides are equal. So x has got to be 50 degrees, okay? And then we say isosceles triangle, and it is the angle the angles on the opposite sides, on the opposite equal sides of the triangle. Okay, now we have to figure out what is y. So now we need to use the angle sum of a triangle is 180 degrees. So if we look at this triangle, 50 degrees plus 50 degrees plus y equals 180 degrees, because it's the angle sum of the triangle. So 100 degrees plus y equals 180 degrees. So y must be equal to 180 minus 100, which is 80 degrees. And we already put the reason in there. Okay. So now let's have a look at this triangle here. Oh, this triangle here is much more interesting. So first we need to find x. Now the problem with this triangle is that it's actually two triangles. Okay, so let's look carefully here. Can you see here is one triangle? Goodness, this is not a nice pen, but you get the picture. Okay, let's see if there's a different pen here. Can you see here? I'm going to color in this triangle here a little bit orange here. Okay, can you see this triangle here? Triangle BCD. Now if you look at triangle BCD, okay, let's get back to my other brush. If you look at triangle BCD, this is B to C to D and back to B. This marking is over here. Okay, so if we have a look at this triangle here, we've got this marking here and this marking here on this triangle BCD. Okay, so the opposite angles to the congruent sides are equal. So x is equal to 40 degrees. And so then here they like the reason like this, the angles opposite the equal sides of the triangle. Now look, it gets more interesting. Okay, if we have a look on the other side, there's another triangle over here. Can you see this triangle I'm trying to outline in green? Triangle BDE. Okay, so this one's got y in the corner here, but can you see this same marking is over here as well? So if you look only at the green triangle, it's going to follow exactly the same rule. This is an isosceles triangle. It's not similar to the other triangle, even though they share a side, but it is still an isosceles triangle. So the rule is the angle is equal opposite the congruent side. So if this one on the bottom is 20 degrees, this other one y has also got to be 20 degrees. And the reason is the angles on the opposite equal sides of the triangle. Okay, let me see. I'm not sure if I can rub this out, but I hope you can see here there are two different triangles here. This triangle BCD, okay, and the marking was for this triangle BCD, the orange one, and the other green marking was for the triangle BDE. And triangle BCD is isosceles and triangle BDE is isosceles, but even though they share a side, they are not similar. Okay, now let's look at this last one over here. This one looks like a challenge. Okay, we've got the same thing going on over here. There is this skinny little triangle. Look here, triangle A, B, C. Can you all see triangle A, B, C? It's this skinny little triangle over here. And then there's a marking here, and there's a marking here for triangle A, B, C. And exactly the same rule applies. Look at this skinny little triangle like this. If I were to take it out and draw it, this is triangle A, B, C. And so when it's by itself, you can maybe see a little bit better. And it says to you this angle here is 84 degrees. And can you see it's opposite that side? So we need the one that is opposite this side. So X is going to also be 84 degrees, because it is the angle opposite the equal sides of a triangle. Okay, for this rule I would also accept if you wrote something like triangle ABC is isosceles, and then you write base angles of isosceles triangles. Okay, I'm abbreviating it there because I'm running out of space. Okay, now have another look here at this figure here. Can you see there is another triangle, triangle ACD? Okay, can you see that? So if I redrew it over here, if we go from A to C to D. So here was A, here was C, here was D, and there were two markings on this triangle. Can you see these two markings over here? Okay. And that means that this is also an isosceles triangle, and they told you this angle is 20 degrees. Can you see it over here? So exactly the same rule applies. It's an isosceles triangle. The opposite angles are equal. So this angle here is going to be 20 degrees, and it's because the angles opposite equal sides of a triangle. Okay.